Hi everyone and welcome back to your channel. Let's solve an example in wastewater engineering in FE and P exam in civil engineering. So this question is in a wastewater effluent in terms of BOD5 removal. So we have like a wastewater treatment and a river, and the flow rate and also concentration of BOD5 of both are provided, and we want to know what is the ultimate BOD in the mixed flow. So again, we have a upstream river and a wastewater depleted to this river, and it intersect with the river, and after that we have a mixed flow which includes the river flow and also the effluent of our wastewater. At the we have like the flow rate of river is 18 CFS, BOD5 of the river is 4 milligram per liter, a flow of wastewater is 4 mgd. At the very release point, be careful about that to the river, and the concentration of BOD5 of the effluent of wastewater is to 20 milligram per liter. You can see it's much higher than BOD5 in the river. We want to know what is the ultimate BOD in a mixed flow. So let's jump to our question is asking about ultimate BOD in our mixed flow. So if we do know that if this is BOD5, so we just go with the BODT, and T stands for 5 days in the mixed flow. And if we just jot down if first we convert the river flow in terms of from CFS to MGD, so 1 feet cube is equal to 7.48 US gallons, so 18 cube feet per second is equal to almost 11.63 MGD or million gallon per day. So if that's the case, now we can write down the a mass balance 11.63, our flow times the concentration of 4 milligram per liter for our river is equal plus the concentration, a flow of a wastewater effluent times the concentration of that is equal to, if you add these two up, is equal to the mixed flow, that's 15.63 times this concentration, its concentration, and that concentration is the BOD at 5 days for the mixed flow in terms of milligram per liter. If you do the math, it just gives you X is equal to 8.09 milligram per liter. But be careful, this is not the ultimate BOD. This is the BOD sub T at the 5 days, and we still need to, this is an interesting problem because we need to use the microbial kinetics formula from the FE and P reference. If you want, I will provide you with the link to the previous video for water resources that we just use this equation for a water resource example. In this wastewater example, it just mixed the wastewater with the microbial kinetics in water resources part. So again, ultimate BOD is biological oxygen demand at the time of T over 1 minus e to the power of negative k constant times T per day. So we have our constant base of our problem statement, which is 0.23. Our time is definitely BOD5, so that's 5 here. We already calculated our BOD at 5 days, which is 8.09. That, and it gives us ultimate BOD is 11.84. If we just jump to our problem, you can see the constant here, you can see the concentration, and if you rush to the problem, you will go by choice B because it just very, you have to calculate BOD5, then from BOD5 you have to calculate the ultimate BOD, which is 11.84. You can see how both these two answers are provided in the multiple choices. The answer is choice C. Thank you. We'll solve more problems in wastewater treatment.